Greatest common factor. You're planning a party and want to give your guest party favors. You have 24 chocolate bars and 36 lollipops. Questions. Number 1. What is the greatest number of party favors you can make if each bag must have exactly the same number of chocolate bars and exactly the same number of lollipops? You do not want any candy left over. Explain. Number 2. Could you make a different number of party favors and still have the candy shared equally? If so, describe each possibility. Number 3. Which possibility allows you to invite the greatest number of guests? Explain. Number 4. Uh-oh, your little brother ate 6 of your lollipops. If the candy bars are shared equally and you do not want any candy left over, what is the greatest number of party favors you can make? Explain. We can use prime factorization to find the greatest common factor. Step 1. Factor the given numbers into primes. 2. Circle the factors that are common. 3. Multiply the common factors together to find the greatest common factor. Use prime factorization to find the greatest common factor of 12 and 16. Alright, so 12 is 3 times 4. 4 is 2 times 2. So we have 3, 2, and 2 multiplied together to give us 12. Here we have 16, which is 4 times 4, which is 2 times 2 times 2 times 2. So we have 2 times 2 in both of these. Therefore, the greatest common factor is 2 times 2, which is 4. Here's another way to find prime factorization. So we have 12 and 16. So we divide this by 2, we get 6. Divide that by 2, we get 3. Divide this by 3, we get 1. Take the 16, divide by 2, we get 8. Divide by 2, we get 4. Divide by 2, we get 2. Divided by 2, we get 1. So then you just multiply these numbers all together. So we have 2 times 2 times 3 times 1, 2 times 2 times 2 times 2 times 1, and then we can circle the greatest common factor is 2 times 2 equals 4. Use prime factorization to find the greatest common factor of 60 and 72. Alright, so for 60 is 6 times 10, 6 is 2 times 3, 10 is 2 times 5. So 2 times 3 times 2 times 5 gives us 60. For 72, 6 times 12. 6 is 2 times 3, 12 is 3 times 4, 4 is 2 times 2. So we have 2 times 3 times 3 times 2 times 2. So we can pull out 2 times 2 times 3 and a 2 times 2 times 3, and that gives us 12. Here's another way to find it. 60 divided by 2 gives us 30, divided by 2 gives us 15, divided by 3 gives us 5, divided by 5. So we have 2 times 2 times 3 times 5. On this side, we just do the same process, and we see that we get 2 times 2 times 3 in both of these. So the greatest common factor is 2 times 2 times 3, which is 12. Use prime factorization to find the greatest common factor of 36 and 90. For 36, we have 6 times 6, which is 2 times 3 times 2 times 3. For 90, we have 9 times 10, which is 3 times 3 times 2 times 5. So we have a 2, a 3, and a 3. Multiply those together, and we get 18. And here's the other way to do it. 36 divided by 2 gives us 18, divided by 2 gives us 9, divided by 3 gives us 3, divided by 3 gives us 1. And then 90, we do the same process down, and we get 2 times 3 times 3 in both of them. Therefore, the greatest common factor is 18. Here's an interactive website that is a review of factors, prime numbers, and composite numbers. Play the factor game a few times with a partner. Be sure to take turns going first. Find moves that will help you score more points than your partner. Be sure to write down strategies or patterns you used or discovered during the game. Alright, so here's the game for 2 people. And so the first person chooses a number, say 12, and then we get 12 points. Player 2 now chooses all the factors of 12. So 1, 2, 3, 4, and 6. Oh, but look, there's a lot of factors of 12. So they just got a lot of points. So that was actually a bad first move on my part. Alright, so now player 2 chooses a number, say 10. So they just got 10 more points. Now I have to, player 1, pick factors of 10. Well, these are all taken, so there's only 5. So that was a good move on their part because now I've only gotten 5 more points. Player 1 choose a number, 14. Now player 2 can choose only 7. So you just continue this way until, so we have 16. Now player 1 has to pick the factors, which is 8. Player 2 has 1. Alright, so the rows and columns here can be adjusted prior to starting the game. Player 1 chose 24 to earn 24 points. Player 2 finds 1, 2, 3, 4, 6, 8, and 12 and earns 36 points. Player 2 then chose 28 to earn 28 points. Player 1 finds 7 and 14 are the only available factors and earns 21 points. Discussion questions. Make a table listing all the possible first moves, remaining factors, including proper factors and 1, your score and your partner's score. Here's an example. What number is the best first move? Why? Choosing what number as your first move would make you lose your next turn. Why? What is the worst first move other than a number you chose in question 3? Well, the first 4 rows are shown in the table. The total number of rows should match the total number of cells in their table, range from 16 to 100. 2. The highest prime number is the best first move. Prime numbers do not have any proper factors, which would make the partner score always 1 on their first move. Number 3. The number 1 would make you lose your next turn. It does not have any other factors. Number 4. A high composite number that has many factors is the worst first move. It would allow your partner's score to be much higher. On your table, circle all of the first moves that only allow your partner to score 1 point. These numbers have a special name. What are these numbers called? Are all of these numbers good first moves? Explain. Number 6. On your table, draw a triangle around all the first moves that allow your partner to score more than 1 point. These numbers also have a special name. What are these numbers called? Are these numbers good first moves? Let's see. Number 5. The numbers that only allow your partner to score 1 point are prime numbers. Prime numbers are a good first move because your partner can only score 1 point on their first move. Number 6. Numbers that have more than 1 factor are called composite numbers. No, these are not good first moves. It gives your partner a chance to score higher than you. The number 24 from the example slide. Second intro slide to this activity. 2 or more numbers are relatively prime if their greatest common factor is 1. For example, 15 and 32 are relatively prime because their greatest common factor is 1. Name 2 numbers that are relatively prime. 14 and 15, 21 and 25, and so on.